Okay. So, with indexes. Now, so you know what is index and how it works. How index works. How index improves performance. Okay, now then. If you create index like this, you create index on salary. If you create index on salary, internally one structure is created. What the structure is? B tree, balanced tree, balanced tree. And with the help of this structure, SQL server locate the data fastly. Okay, na? Then what this is called? Root node. What this is called? Intermediate nodes. What this is called? Leaf nodes. Okay, then. So when you submit a query, salary equal to 3000. Salary equal to 3000 means what it will do? So salary equal to 3000. Then 3000 is what? Compared. So equal. If it is equal, left side. Equal or less than, left side. Greater than, right side. So given value is 3000. 3000 equal. Then go to left side. And 2000. Given value is 3000. But here 2000. 3000. Then right side. 2500. So, but you're asking 3000. Condition false. Here what's true. And take this address, go to table, get the record from the table. How many comparisons? 1, 2, 3, 4. In 4 comparisons, you're able to find salary equal to 3000. If you go to table, how many comparisons required? 8 comparisons. Every row you have to check. So total how many comparisons? 8. If you go to index, how many comparisons? 4. Number of comparisons will be reduced to half. Because you have to compare only one side, left side or right side. Yes or no? Then next. Even if you give greater than or equal to 3000 also, greater than or equal to 3000. 3000 equal. Next, like go to left side, 2000, 3000. Go to right side, 2500. No. So 3000. Yes, selected. And also select the nodes which are right side to this 3000. Because all these leaf nodes are interlinked. There is a interlink between the leaf nodes. So 3000 is selected. And also select the nodes which are right side to this 3000. Without any comparison, it selects all the nodes right side to this 3000. Suppose he given less than or equal to 3000. Then again it takes 3000. 3000 is compared. Go to left side. 3000 is compared. Go to right side. 2500. Yes, selected. 3000 selected. And also select the nodes which are left side to this 3000. The nodes which are left side to this 3000 are less than 3000. Yes, this is how index works. Now, and this index is called what? Simple index. This is called simple index. And what this is called? Composite index. When index is called composite, if index is created on multiple columns, if index created on multiple columns, then index is called what? Composite index. So department number comma job. So I created index on department number comma job. So this index will be created something like this. Okay, na? Index will be created something like this. Then index will be created like this. So here root node and intermediate nodes are based on what? Department number, and leaf nodes contains department number and job. Okay, then. So if you give department number equals to 20, if you give department number equals to 20, 20 is what? Compare. So 20 is equal to 20. Then go to left side. 10, 20 is compared. 20 is greater than 10. Go to right side. 20 clear. 20 manager. Both are selected. Take this address, go to the table, fetch the records from the table. If you give 20 and job equal to clerk, then given value 20, 20, 20, go to left side, 10, 20, go to right side, 20 clerk, because you're asking 20 clerk now. So 20 clerk, it take this address and fetch the records from the table. Job equal to clerk, will it use index? No, it will not use index. Why? So to use index, what is required? Department number is required, because here leaf and intermediate nodes are based on what? Department number, but the given value is what, sir? Job. Sir, okay na? That. So for this query, it will not use index, it will use table scan. Okay, then. Understood that. So like actually, when this will be useful, when this composite index, when we create composite index, when we create simple index, how you decide whether I should create composite index, I should create simple index, how you decide? You decide based on what, sir? Queries. Decide based on where conditions. Yes, your where condition is based on, sir, your where condition is based on only department number. Then that's all. This query is running slow. Then create index on department number. But there are two queries. What user is saying, this query, both queries running slow. Job equals to clerk. Both queries running slow. Better to create index on. Sir, there is only one query. This query is running slow. Create index on department number. Both queries are running slow. Then create index on department number, comma, job. If you create index on department number, comma, job, both queries will take the advantage of index. Both queries will take the advantage of index. This query will take the advantage of index. This query also takes the advantage of index. Both queries will use index. Suppose if we create index only on department number, then this query will take the advantage of index, but this query will not take the advantage of index. Understood or not understood? Huh? Understood now? What boss here actually, here how you decide composite index is required or not required, or simple index is enough, or do we need composite index? How you decide? Based on the queries. User is saying that boss, this query is running slow. Then what? This query is running slow. Then what you do? Create index on department number. Then this query performance is improved. But user is saying that these queries, both queries are running slow. Then what is the best option you have to find out? What that is? Create index on what? Department number, comma, job. If you create index on department number, comma, job, what the advantage is? This query will use index. This query also uses index. Both queries will use index. If you create index on department number, comma, job. Understood? Then if you create only on department number, what is the problem? If you create only on department number, only this query will use index, but this query will not use index, because here what? It is based on department number and job. But if you create index on department number, comma, job, then both will take advantage. This query will take the advantage of index. This query also takes advantage of index. Understood? That. So it all depends on the queries. Like 1 second. Then what is just one more is there? What is that is? Unique index and cluster index. There are two. Unique index. Unique index. Unique index. What is unique index is? Unique index does not allow duplicate values. Unique index does not allow duplicate values into the column on which index is created. Unique index does not allow duplicate values into the column on which index is created. Does not allow duplicate values into the column on which index is created. Then so let's see. On whichever column unique index is created, into that column duplicates are not allowed. Just see this 1 second. Suppose here, then what I'm doing is, let's see. I'm creating index, create index I3 on EMP in brackets what? Ename. 1 second, 1 second. If you create like this is normal index. This index is what? Normal index. It allows duplicates. It allows duplicates. You see the previous example. Here, this is normal index. It allows duplicates or not? Yes. How many employees are there? There are 2 employees, 3000. So that's why there are 2 addresses. Next one. This also allows what, sir? Duplicates. There are 30 salesmen. There are 2 employees. It allows duplicates, normal index. But unique index does not allow duplicates. But how to specify this is unique index? So it use this keyword unique. Create unique index. When you use unique, then this index is called what? Unique index, and it will not allow the duplicates. That's all. Example, say this. I'm creating unique index on ename. But just example, actually enames can be duplicated, but just example how unique index works. For example, I'm taking this, but actually if you take, okay, na? Enames can be duplicated. There may be number of employees with same names or not. Yes. Duplicates are allowed into ename. Yes. But just example, I'm creating unique index on ename. So it will not allow duplicates into what's sir? Ename. Now, your index is created on ename, but ename is what? Ename is character column. Ename is what? Character column. So if it is character column, then how the tree is created? If it is a numeric column, you know, if it is a numeric column, so values are less than or equal left side, values are greater than right side. Yes. But if it is a character column, ename is a character column, then it is based on alphabets. Okay, na? Let's take, suppose for example, K, K left side, G left side. Okay, na? Suppose name is Adams, like star. Name is Ellen. There is a name called Ellen. There is a name called what's sir? Blake. All this character before G comes left side. Okay, na? The character that comes after G goes to right side. J, like James, star. There is a name Jones, star, like this. James Jones, like this. Okay, na? Then K right side. K right side. What is that is? Let's say Q left side. Okay, na? Okay. M. Martin is there. Martin star. Next one, Miller star, like this. Next one, Q right side. Q right side. What? Q right side. Then S, like Scott star. Next one, Smith star, like this. So this is what then. Okay, na? Like this. Understood? Then so the tree will be created something like this. Okay, if you create index on ename, the tree will be something like this. Next, let's see. And what this index is? What this index is? This index is what index? Unique index. Unique index does not allow duplicates. When index does not allow, into the table also, in table also, duplicates are not allowed. Index does not allow bars. When index is not allowing the duplicates into the table also, you cannot insert the duplicates. Yes or no? Okay, na? When SQL server will use this index, when SQL server use the index, SQL server will use index when SQL server uses index. Forget about this one. Any index, when SQL server use, when you submit a query, in that query where condition is based on index column, then it will use that index. Yes or no? That means you submitted a query like select star from what emp where ename equals to Blake. Select star from emp ename equals to Blake. When you submit this query, then what? It will check any index is there on ename. Yes, there is an index I3. It go to this index. So compare B with K. Then go to B compared with K bars. Go to left side because B is less than K now. Go to left side. Go to left side. B compared with G. Then left side. Adams. No. Allen. This is leaf nodes now. This is leaf nodes. Any leaf node is there with name Blake? Yes. Then take this what? Address. Go to table. Fetch the Blake record and display the Blake record. So it go to find this Blake and take this address. Go to table. Fetch the Blake record. How many comparisons? 1, 2, 3, 4, 5. 5 comparisons. In 5 comparisons, you are able to find out the Blake record. Yes or no? Okay, na? For this query, it will use index. So then next, and what is this index is called? This index is called unique index. Unique index does not allow duplicates. What I am doing is I am inserting a new record into EMP table. I'm inserting a new record into EMP table. EMP NBO, ename, salary, values. So number is something 88. Name is what's that? Blake. And salary is what? 4,000. I'm inserting a new record into EMP table. When you insert a new record into table, this should be inserted in index or not? Whenever you insert a new record into table, that entry will be inserted into index or that entry will be inserted into index or not? Yes or no? Sir, simple. When a new topic is added to textbook, the topic should be there in the index. Same thing. When a new record inserted into table, that should be there in the index also. When new topic is added to the textbook, the topic should be there in the index. When you insert a new record, they should be there in the index also. Yes or no? Okay. Then what it will try? It will try to insert this into index. But in index, what is inserted? Full record is not inserted. What is inserted? In index bars, what is inserted? Only name. Name is inserted. Okay, now in index full record is not inserted. Only name is inserted. What is the name? Blake. Blake is compared with what? K. Go to left side. G. And Blake is compared with what, sir? G. Go to left side. Adams? No. Allen? No. Blake? Yes. Blake? Yes. Then Blake? Yes. Yes. Okay, na? So record is already there or not? Yes. What you are trying to do? You are trying to insert what, sir? Duplicate. Blake is already there, but you are trying to insert what? Duplicate. But what this index is? Unique index. Unique index does not allow duplicates, but you are trying to insert duplicates. What this command gives? This command gives error. Understood? Then, if you want, you can check. First, create the index. Index is created. After creating the index, I'm inserting a new record into table. Okay, na? I'm inserting a new record into table. So let's see this. Insert the new record. But Blake is there or not? Table already contains what's that? Blake. But you are inserting what's that? Duplicate. Then what it is giving? Error. What is the error? Cannot insert duplicate row with unique index I3. Cannot insert duplicate with unique index what's that? I3. Understood? So this index is created on what? E name. But so you're trying to insert what's that? Duplicate. That's all. What is the difference? Normal index, unique index. Normal index allows duplicates, but unique index does not allow duplicates. Then my question is, how many how many ways to enforce uniqueness? How many ways are there to how many ways? How many methods are there to enforce uniqueness? How many methods we can enforce uniqueness? Uniqueness. What are the different methods to enforce uniqueness? One. Oh. So, yes, there are two methods. One is declare what's that? Primary key or unique constraint. Second method, create unique index. How many methods we can enforce uniqueness? Two methods. One method is declare primary key. Second method, create unique index. Understood? Then okay, na? Then so no. And one more point is then we don't need to create index on primary key column. We don't need to create index on primary key column. Primary key columns are automatically indexed by SQL server. SQL server automatically creates what's that? Index on primary key column. Listen. We don't need to create index on primary key column. SQL server automatically creates index on primary key column. What type of index is created on primary key column is unique index is created. Unique index is created on primary key column. Unique index does not allow duplicates. So primary key does not allow duplicates. Understood the point? So tell me how primary key is internally implemented in SQL server. How primary key is implemented in SQL server? By using unique index. When you declare primary key, on that unique index is created. Unique index does not allow duplicates. So primary key does not allow duplicates. Got it? Then you want to check, you can check. Suppose create table, something, customer ID. Just see this integer. What is this is? Primary key customer name, varchar of 10. I'm declaring primary key, but I'm not creating any index. Then create this. So table is already there. Drop table, what's that? Customer. Table is already there. Next, create the table. Table is created. After creating the table, check any indexes are there on this. How to see the list of indexes? SP help index customer. Command to see the list of indexes on customer table. So just see this here. Then one index is automatically created. I have not created this index. What is the type of index? You see that unique index. Unique index is created on customer ID. Okay, then, and this unique index does not allow duplicates. So primary key does not allow duplicates. Okay, then one point is then primary keys and unique columns are automatically indexed by SQL server. Unique columns are automatically indexed by SQL server, and unique index does not allow duplicates. So primary key also, sorry, automatically indexed by SQL server, and SQL server once again, and SQL server creates unique index on primary key unique columns, and unique index, okay, then unique index does not allow duplicates. So primary key also, primary key unique also does not allow duplicates. Sir, okay. Then that's all. So this is what about unique index. So maximum unique index is what? We don't need to explicitly create unique index. We don't need to explicitly create what's a unique index. Why? We don't need to create unique indexes, bars. Instead of creating unique indexes, then what you do? Declare primary key or unique consent. Why we create unique indexes? To not to allow the duplicates. Then declare primary key or unique consent. When you declare primary key unique also, internally index is created or not? Yes. Okay, na? Then no. Okay, na? That's all. So this is about what unique indexes. Just one is left. Then So if you want to check, then this is the example. If you want to check, create the table, declare primary key, and check whether index is created or not. How to check? To check whether index is created or not, SP help index customer. Okay. Okay, that's all. So this is create the table, declare primary key, and check whether index is there created or not. Okay, now then it will show one index. What that index is? This one, clustered unique index. Okay, what is this? Is index name. Have we given this name? Who is given this name? SQL server. I am not given this name. SQL server is given this name. Okay, then. Okay, then. One is left. What that is? Cluster index. Cluster index. Then. Oh. So, like the indexes till now we created this index and this index and this index. The indexes till now we created. All these indexes are called non-clustered indexes. All these indexes are called non-clustered. Non-clustered indexes stores addresses to the actual record. Non-cluster index stores what? Addresses, pointers to the actual record. Where is the actual record? Table. Where is the actual record? Table. Non-cluster indexes stores pointers to actual record. Pointers means addresses. Whereas cluster index stores the actual record. The record is stored in index. The record is stored in what's it? Index. But here the record is not stored in index. What is stored in index? Only salary plus address. Salary plus address. But actual record is stored in table. So index stores only the salary plus address. But whereas cluster index stores what's it? Actual record. Actual record is stored. So that is the main difference between a non-cluster and a cluster. So then a non-cluster index stores pointers to actual record, whereas cluster index stores actual record. A non-cluster index stores pointers to actual records, whereas cluster index stores actual record. This is the main difference between non-cluster and cluster. Okay, then let's take example. Okay, now suppose here. See that next. I am dropping the table dropping the customer table, drop table, customer table is dropped. Again, I'll create the table. I'm creating the table, but in this customer ID is there. Customer ID. Let's remove this primary key, then comma, next one. So this is the table. Next, I create what's that? Create what? Index. I want to create index on customer ID. And once again, just see, create what's that? Index I10 on customer, which field? Customer ID. I want to create index on customer ID. But if you create like this, what is this index is? If you create index like this, what is this is? Non-cluster. This index is non-cluster. Okay, na? Then, but I want to create what's that? Cluster index. To create cluster index, say what? Cluster. To create index, cluster index, say cluster. If you don't specify anything, by default is non-cluster. Then non-cluster index stores pointers. You want to create cluster index, then say cluster index. Create cluster index on customer ID. Okay, na? Then listen, first listen this. After creating this, next you insert the data into what's that? Customer table. Insert data into customer table. Insert into customer values. Customer ID is what's that? 10. Name is something A. Okay, na? You insert the record. When you insert the record, this is inserted into index, no? Yes or no? Because you created index on customer ID, then index. So index will be something like this: 50, left side of 50, suppose 30, right side of 50, what's that? Some 60 or 70, something. Okay, na? Now, where this is inserted? Left side of 30, left side of 30. What is inserted earlier? 10 star. Earlier, what is inserted? 10 star. So because you created index on customer ID, what is the customer ID? 10 and star. What is the star is? Address of the record. But what is this index is? This index is what's that? Cluster index. What is cluster index stores? Actual record. What is the actual record? 10A. This record is stored here. What is stored? Record. This complete record is stored here. Customer ID, name. If address is there, address is also stored here. It will not store pointer. It will store record. Okay, na? The record is stored in index. Next one. I insert one more record. What this is? 80. 80 or okay, let it be 60B. 60B. I'm inserting a new record. Where 60 is inserted? 60 is greater than 50. Go to right side. 60 compared with 70. Go to left side. Where 60 is inserted? Here. 60B. The record is stored in index. Next one. Suppose I want to insert what's that? I'll insert. Suppose what then? 40C. Where the 40 is inserted? Right side of 30. 40C. 40C is inserted here. Yes or no? Okay, na? Then next to, like, let's see one more record. Suppose I'm inserting 80D. 80D. Then right side of 70. 80D. 80D is inserted here. Right side of 70. Understood? Then so this is the created. What it is storing? Record. Record is stored. Here table is not separate, index is not separate, table and index is one. Okay, na? The table data stored in index. Okay. Now, what is the advantage? What is the advantage? What is the advantage of cluster index? Now, earlier, 1 second, compare. Earlier, sir, this is the index. Okay, na? This is the index. Index is created. Now, you submit a query, salary equal to 3000. Where salary equal to 3000. Then what it has to do? You submit a query boss where salary equal to 3000. You want salary equal to 3000. Then what it has to do? It has to go to this one. It has to go to this one and find out salary equal to 3000. Go to left side. Then next right side. Then find out this 3000. Yes. Then take this address and go to table. Fetch the records from the table. So tell me how many lookups are required? How many lookups? Two. One is in index, one is in table. First, it has to go to index, like find the address and go to the table and fetch the records from the table. How many lookups? Two. One in index, one in table. Now let's see here. Suppose here in this case, now select star from EMP. I submit a query. Select star from EMP customer where customer ID equal to 60. I want customer ID 60 record. Then 60, 60, 50 is compared. Then go to right side. 70, 60 is compared. Go to left side. 60 is there or not? Yes. And this record is selected. Does it need to go to table? No, it doesn't need to go to the table because the record is there in index only. It doesn't need to go to the table. How many lookups are required? One. That's it. Okay, na? Okay, first created the table, next created the index, now inserted the data into the table. After inserting the data internally, index will be created like this. Then index will be created like this. Now when you submit this query, what that is, select star from customer where customer ID equal to 60. Then what? Earlier what? Earlier if it is a non-clustered, then what? Non-cluster. Explain non-cluster. First it goes to index, find out the record in index, take the address, go to table, fetch the record from the table. So how many? Two. One in index, one in table. Now here, then so go to index 50. So 70 is compared. So 50, 60 is compared. Go to right side. 70, 60 is compared. Go to left side. 60. Okay, na? Record is there, na? So does it need to go to the table? No, because the record is there in index only. It doesn't need to go to the table. Okay, now then. Sir, okay. Now, if you want to test, you can test like 1 second. First, create the table. First, create the table. Table is created. After that, create what's that index. Index is created. Yes. Next one. Insert the records into the table. In which order you are inserting? 10, 60, 40, 80. 80. In which order? Then. How many rows inserted? 4 rows. Now you run the query. Okay. Select star from customer. Select star from customer table. So tell me, when you run this query, what happens? There is no where condition. Then what happens? Huh? Sorry, here table and index is not separate. Table and index is only one. Your data is not separately stored in index. Data is not separately stored in table. Data is stored in only one place. What is that place? Is cluster index. Data stored in only one place. What is that place? Is cluster index. Your table and index is not separate bars. Table and index is only one. So then cluster index. When you submit this query to SQL server, then what it will do? It will go to this cluster index. It will go to the cluster index and go to the cluster index, access all the data left to right. Access all the rows from left to right. So first what is displayed? 10, next 40, next 60, next 80. But in which order you inserted? First 10, next 60, next 40, next what's that? 80. Actually, when you run the query, it should display in which order? In whichever the order you inserted, in the same order it should display. Yes or no? You inserted 10, 60, 40, 80. But in which order it will display? 10, 40, 60, 80. Okay, na? But why? Because it is not getting the data from table. It is getting the data from cluster index. In index, left to right, the nodes are arranged in ascending order or not? If you see the index structure, left to right, the values will be in what's that? Ascending order. So then, now see this here. Select star from customer 10, 40, 60, 80. But I inserted like this. 10, 60, 40, 80. But it is not showing like that. It is showing what's that? 10, 40, 60, 80. So it is getting the data from where? Cluster index. Okay, then. So when you submit this query to SQL server, select star from customer table. Then SQL server goes to cluster index and reads all the nodes from left to right. Access all the leaf nodes from left to right. So that is why what is the output? You'll get the output like this: 10A, 40C, 60B, 80D. Okay, na? Then next. Oh, next one, like what? Only like, and one more thing. That's all. This is about cluster index. But and in a table, only one cluster index is allowed per table. Only one cluster index is allowed per table. Only one cluster index is allowed per table. You cannot have multiple cluster indexes. Okay, na? Then only one is allowed per table. So then let's see. On this customer table, one index is created or not? One cluster index is created or not? Yes. On which column you created? Customer ID. Suppose, for example, create what's that? Cluster index I20 on customer table, customer name. I'm creating one index. What is the index name? I20. Then let me create this. It gives error. What it says? Cannot create more than one cluster index on table customer. Then what it is saying? Drop the existing cluster index I10 before creating what's that? Another. So before creating another index, first drop the existing cluster index. So how many cluster indexes allowed per table? Only one. And one more thing. So then, and SQL server, by default, SQL server creates what's that? By default, SQL server creates cluster index on primary key column. So, okay, by default, SQL server creates cluster index on primary key column. So on primary key column, what type of index is created? On primary key column, what type of index is created? Clustered. Clustered unique index is created. Clustered plus unique. Only one is allowed. That too, it is created on what? Primary key columns. Okay, then. So you want to check, you can check. If you want to check, you can check. Like, let's see. 1 second. Suppose here, again, drop the table. Drop table, what's it? Customer. Table is dropped. Create table, what? Customer. Customer ID. Integer. Declaring what? Primary key varchar of 10. So I'm creating table then, but one index is created. Yes or no? Let's go and see. SP help index customer. Then let's see this. One index is created. What is this type? Clustered unique. Clustered unique. Okay, na? Then. So it is clustered and also unique index. Then. So what type of index is created? Primary key column. Answer is what? Clustered unique index. Then next. Another question is, what is the difference between the last non-clustered and clustered index? What is the difference between non-clustered and clustered index? Okay, what is the difference? Then first one, non-cluster indexes stores what? Pointers to what? Actual records. Whereas cluster index stores actual records. Okay, then next, in non-cluster index requires extra memory, requires extra storage. Here, data stored in table, data stored in index. Table is separate, index is separate, needs extra storage. Cluster index, table data, index data is stored in only one place. So doesn't need extra storage. Non-cluster index needs extra storage. Yes, sir? Yes, sir? No. Here what? Here table was. This is table. So data stored in what? Table. Data stored in table. And data stored in index also. The data stored in table and data stored in index. But table stores complete row. Index stores only salaries. But needs extra storage or not? Yes. But cluster index what? The data stored in only one place. Where it is stored? It is stored in cluster index. So doesn't need extra storage. So this needs extra storage, but this doesn't need extra storage. Next. So if you want to find out the record, how many lookups required in non-cluster? Two lookups. One is in first, one is in index. Next one is in table. But here only one index. Okay, na? Then. So requires what? Requires two lookups to find the record. Then, but whereas this requires one lookup. This requires one lookup to find the record. Okay, and next, how many non-cluster indexes allowed per table? How many non-cluster indexes allowed per table? SQL server allows how many? 999 non-cluster indexes per table. Allows 999 non-cluster. How many cluster indexes allowed per table? Only one. Only one cluster index. Only one cluster index allowed per table. Total how many indexes allowed per table? Total how many indexes allowed per table? Like question is how many indexes allowed per table? 1000. 1000. 999 non-cluster plus one cluster. Total how many? 1000. 1000 indexes allowed per table. Okay. Then. And non-cluster indexes created explicitly now, implicitly now. Non-cluster indexes. Like created what's that? Explicitly. Cluster indexes created implicitly on primary key column. Yes or no? Non-cluster indexes created what? Explicitly. Explicitly means created by user. Created by user. Then explicit. Next, cluster indexes created implicitly on what's it? Primary key column. That's all. So this is the difference. So okay, then then how to see the list of indexes? SP help index. How to drop indexes? Dropping index. How to drop index? Drop index what's it? Index name emp.i1. You cannot say I1. You have to say emp.i1. Index is what? Drop. You have to say emp.i1. Index created on emp table. So okay na? Then. But if you drop table, what about indexes? If you drop table, what about indexes created on table? No. If I drop the table, I'm asking what about indexes created on table? Table is dropped. Dropped. Then what about indexes? Indexes are dropped or not dropped? Indexes are also dropped. Okay na? How many indexes are there on EMP? SP help index. What's that? EMP. You see that? How many indexes are there? 2 indexes. Drop table. What's that? EMP. EMP table is drop. SP help index EMP. Then object EMP does not exist. What about indexes? Gone. Indexes are also dropped. Answer. Indexes are also dropped. Okay. Then. Oh. So actually, sir, here there is a what server. Inside the server, what you create? Database. Inside the database, what you create? Tables. Just see this. Views. Next one, what's it? synonyms. Okay, na? Use synonyms. Next one, what? Tables. Tables contains what? Rows and columns. Table contains what? Constraints. Table contains indexes. Table contains triggers. But this you don't know. You'll be knowing this in later. And that's all. If you remember this hierarchy, then you can able to answer. If you drop table, what are dropped, what are not dropped? If you drop the table, what are dropped, what are not dropped? If I drop the table, what are dropped? Rows and columns are dropped. Constraints are dropped. Indexes are dropped. Triggers are dropped. Views are dropped or not dropped? Not dropped. Synonyms are dropped or not dropped? Not dropped. So these objects are dropped. If I drop database, all these are dropped. If your server is gone, databases are gone. Database is gone. Whatever objects are there in database, they are gone. If server is gone, databases are also gone. Server contains 100 databases. All the 100 databases are gone. Okay. Now. Okay. So in this SQL part is what's it? Completed. Okay, na? There actually, I think just two more left. One is merge command. Another one, what's that? One operator. What that operator is? Pivot. Okay, na? Then. But if you want, we'll see this later. Merge pivot. Okay, then SQL is completed. Okay, na? Next, like what the next topic is? Next topic is what's it? TSQL programming. Next one is this TSQL program. Okay, then. So here you learn commands. Next we'll write what's it? Programs. Okay, then how to insert the data, how to update the data, how to delete the data, like you directly submitted the commands. Next we'll do this through programs. What is the advantage? You'll know that. Like simple example is drop table emp. What this command will do? Drop the emp table. I want to drop all the tables from database. Then I want to drop all the tables from database. Database contains 20 tables. I want to drop all the 20 tables. Now, if you drop database, views are also dropped. Synonyms are dropped. I don't want to drop other objects. I want to drop only the tables. Okay, then. So their programming is required. There what's it? Programming is required. You want to drop single table, program is not required. But you want to drop what's it? Multiple tables, then program is required. Take a loop. Take what's it? Loop. In loop, execute drop command. Sir, okay, na? Then. Next, if condition true, I want to execute update. Condition false, I want to execute delete. There, this is where programming is required. I want to execute the SQL commands based on what? Execute the SQL commands based on condition. If condition true, I want to execute one SQL command. Condition false, I want to execute a different SQL command. So this is where programming is required. Okay, na? Then maximum in real-time application, we don't execute the commands directly, straightforward. Always commands are executed based on conditions only. Yes or no? Okay, then. So that case programming is required. So we'll start in the next class tomorrow. Okay, na?
Column identifications are not just like
Hmm?
this
Hmm.
product ID no, sir.